Recording this lesson.
Hi everyone.
This lesson is on reverse percentages. It's very similar to percentage increase. Yeah. And any other future students who might want to look at this.
Edie? Oh, this is
Edie's
Hi,
alright.
Edie.
Hi,
girl.
So reverse percentages. This is very similar to percentage increase and decrease where you work out a decimal multiplier. So just like before, you'll need to work out a decimal multiplier first. But after you worked out a decimal multiplier, what did you normally do as the next step? Natalie?
You would times
Yeah, you would times the old value by the decimal multiplier. Here, we're doing the reverse step. You need to work out the old value. So you take the new value and you would divide by the decimal multiplier because the opposite of times is divide.
So you do the opposite. You'd have the real answer, then you divide all the answers.
Yeah.
And then would you do? Then would you have to do the 100?
Yeah, that's right. Yes. So you would first of all still work out the decimal multiplier like you did before. No change to that. You still work out the decimal multiplier just the same way. But the second step, instead of multiplying, you just are dividing instead because you're doing the reverse, like you're going backwards. So which sounds weird. So let's see a little example to see what we mean by that. So we've got reverse percentage. Reverse percentage problems require you to work out the old value, like the original, because normally in the question you're given the old value and you times it by the decimal multiplier to work out the new value. But this time you're going to go backwards and you're going to work out the original. What it would have been before, and the key word is before. So before is a really key word in this topic. Before, I'll even circle it, highlight it or something. Before is a really key word because you'll probably see like words like original and before are really key in this. If they want you to find the original value or find out what the value was before, then they will normally want you to do a reverse percentage kind of problem. So reverse percentage problems require you to work out the original amount, what it would have been before the item underwent the increase or the decrease. So that's why, because you're going backwards, you're doing the reverse step. That's why the second step is to divide instead of multiply, because divide is the opposite of multiply. So like before, you still need to work out the decimal multiplier, so like the DM basically. Work out the DM just like you did before. So no changes to the way you work out the DM. If it's an increase, you do 100 plus the percentage, divide by 100. And if it's a decrease, you work out 100 minus the percentage, divide by 100. So work out the DM just the way you used to. But the only thing is, to work out in the second step, you would divide instead of multiply. Divide the final value by the decimal multiplier to find the original amount. Previously you multiplied, like Natalie said, beforehand you would always multiply in the second step. Now in our second step we just divide instead. So the maths you do is actually simple because it's just like what you did before. The hard thing is working out, is this a normal problem or is this a reverse problem? And the key words you're looking for to see if it's a reverse problem, yeah, words like before, and words like find the original. Are keywords that help you realise that it's a reverse one. So in the second step, you would just divide instead. So let's see an example of a reverse problem. So the bill in a restaurant comes to let's just say $70.20, which includes a service charge of 8%. So if it's a service charge, is that a percentage increase or a decrease problem? Yeah, increase, because the service charge is added, isn't it? So that means it's an increase problem. So you've got two things to decide. Is it an increase problem or a decrease problem? For working out the DM. Increase problem or the decimal multiplier step. So that's one thing you want to work out. Is it an increase or a decrease problem for the decimal multiplier? And you work it out just like you did before. If it's an increase, you just do 100 plus 8 over 100. So that's different to the first step. But the second step, we need to see, do we multiply or divide in the second step? So work out the size of the bill before the service charge is included. What's the key word there that tells us it's a reverse problem? Yeah, exactly. Before. So that's a key word. So they want you to find the old value. So divide in the second step. So that's a keyword. Work out the size of the bill before the service charge is included. So that's a little key, the before word. Sometimes the word find the original value is also another keyword. So we just work at the DM like before. So you're writing that first.
So 100 plus 8. So probably like
Yeah.
0.0 over 8 or something.
Exactly, good. And work it out formally because you would, like exactly do this step because you get the point for doing this step. So imagine you made a mistake. If you made a mistake in your second step, if you showed this working out, you would at least get a step for your, or some working out, you would at least get a step for your DM. So as I said in green, this is a reverse percentage problem because it requires you to go backwards in time to work out what the original was. So that's why you don't time.
720 divided by 1?
Yeah, exactly. Always put the DM second. Because when you're multiplying, it didn't matter the order, because 3 times 4 is the same as 4 times 3. But when you're dividing, it's different. Like 3 divided by 4 is 0.75. 4 divided by 3 is 1.3 recurrent. So when you divide, it's important you've got the order right. So always divide the final value by the DM. So always do the old value. No, what am I saying? Always do the value divide by the DM. Put the DM second, because when you're dividing, it's important that the order is correct. When you're timesing, it doesn't matter. So I just always say put the DM second. So what did you say, Xavier?
It's 70.20 divided by 1.08, and it gives you $65.
Where'd you get 70.20 from?
It's in the question. The bill. The restaurant.
Yeah, it's from.
$65.
Yeah, that's right. So we have to tell you what the new value was, well, like what the final value was, and work out what the old value was by dividing. What was it again, Xavier?
$65.
$65.
So then what you do 70.2. So you're not actually finding how much it would all be?
No, you're just working out what it was.
8%.
Yeah. So imagine I went to
Oh, so that was it
Robinhood
before the service?
and I had an expensive meal. Yeah, exactly. So imagine I went to the Robinhood and I had an expensive meal, or I was paying for a meal for a friend and I. And then, so imagine like if I just added up the items on the menu, it would come to $65. But then remember they always charge you gratuity and they get added to your bill. So if I just added up the menu items, it would probably come to $65. But when I get my bill, it would be $70.20.
Oh, so the 65 is not the 8%. It's how much it was originally.
Yeah, exactly. How much it was before they added the service charge on the bill.
That's a lot of service.
Yeah, and actually in Bermuda it's like 17%.
Yeah. When I went with
Flanagan's.
4 friends,
It
it was like 18% service charge. And if you we had like one time.
Where'd you go?
It was like we had a big, yeah.
It was 400 something.
400 something.
For like,
But it would have been less, like $50, more than $50 per
no,
ticket.
but the thing is, a lot of the
That wouldn't surprise me, yeah. That's
It
huge,
was
isn't
way
it?
too
It's
much.
the white
It was
calamari.
only $70 per ticket.
No
And do you realise the only place it doesn't seem to charge you gratuity is the Swizzle? So in the Swizzle, you've always got it in your head. Yeah, like sprinkle in.
You have to add it on.
Yeah, you have to add it on. So when you're in the Swizzle and you get your bill of $65, you've got to think, okay, they were bad, so I have to give them the service. What's about 17% of this? So I use a decimal multiplier.
Do you have to?
What if you didn't go to
You
school?
don't have, no, you
So
don't have.
basically, it's just a tip, kind of.
Yeah, but pretty much if you're from Bermuda, you do, because like you realise that we often go back there. And so like say for example, what I have to do is, I have to do 65 in my calculator times 1.17. I work out the decimal multiplier for a 17% increase.
Your
Would
math.
be 1.17. So I do these things on my calculator. I do 65 times 1.17
So
to
like,
work out what I should charge.
or could I
What I should
ask
pay
the
them.
person to do it?
Yeah, you can.
So
That kind of
it
thing.
would be 60, 76.
But some people can choose to like. Some people might choose to give less than 17%. But
Why would I do that?
Yeah.
Another 5.
So that's what I mean by service charges. They get added on. Here's another one. La 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 la. Okay, cool. So here's another example, just to get the hang of this. So in a sale, a shop reduces its prices by 15%. So is this a decrease or an increase? Decrease, yeah, good. Whenever it says sale, it's or even if they don't say reduces, 15% sale just means reduce. So sale is important and reduces. So it's a decrease. So it's a decrease for the DM step. That's the first thing you want to decide. And then she pays $68. Work out how much she saves by buying it in the sale. This is interesting. It's a little bit more complicated. So the $68, would you say that's the final value that she pays?
No.
Yeah, does that one include the 15% off? So it's in a sale and I buy it. So it's a 15% off sale. And when I go to the register, I pay $68.
Yeah, that's the final thing.
You
Right?
have to take
If it's
off
15% off, you don't pay the 60.
No, but what we have to do is we have to
Good
find
question.
what
Wait, is it-
15% would be.
Okay, let's say she buys a dress for $68. Is that the price of the dress originally or the price after the sale?
That's a good point. So if I'm at the register and am I paying the sale price?
Yeah, I think that was the sale price.
The original
Sale price.
is the sale price?
Yeah. So when I go to the register, I'm not paying the sale price.
Because it says she paid
Oh my God.
$68 and she paid it. Yeah.
Oh,
So we need to see how much 15% is.
Yeah, so first what we need, work out how much she saves by buying it in the sale. That's actually a good question. How much she saves by buying it in the sale. The only problem is we can't work out 15% of $68 won't give us the right amount. It needs to be 15% of what the original value was.
So that is the original value.
Yeah, so what we need to do is work out the original value instead. Because 15% of, imagine the original value was $80. 15% of 80 is a different number to 15% of 68.
So we have to do 0.85 because that's the DM of it.
Yeah, work out the DM, that's true, let's do that first.
0.85.
So DM.
So DM equals, yeah, how did you get that, John?
100 take away 15 over 100 and it equals 0.85.
Good, yeah, so that would get you a nice mark, so good that you did that. And then what we want to do is work out the original
Then
value.
so 68 times, no, divided.
Yeah, good, that's right.
Why is this
68.
one minus 15? Because it decreases. How do you, oh, because it's stale.
68 divided by 6.
Good, yeah. And this would be what the original price was.
haven't we already done that?
80. So it was 80. You said that.
Oh, how weird is that? That was just a random guess. So $80. So therefore, so that normally that's our answer, but this one just asks for one
So
more
then
thing.
we do
How much did I
68,
say?
80 take away 68.
Yeah,
And
exactly.
she
yeah.
saved $12.
That's 80.
At least you didn't spend 80.
Yeah, I would take that.
You could get a good meal at Buzz for $12.
Yeah.
And a drink.
Mm-hmm.
So work out, here I'm just making a note, work out the original value by dividing.
You get a good meal.
Okay, you
Don't
get
have to
But
worry.
you get like
You
five
get
orders.
You guys pay an iced coffee here at Buzz is $7.
away.
It's
It's like
$3.
in a gas station, it's 99 cents.
An iced coffee.
Yes.
But away, iced coffee in a gas station. No, from like Dunkin' Donuts, it's $3. And it's so good.
Okay, yeah, so just summarizing this, sorry, just summarizing this for the video. So we worked out it was a decrease for the DM step, so that's how you worked out the 0.85 in step 1. Then she paid $68, work out how much she saved in the sale. So we had to work out the original value first by dividing in the second step. And to work out how much she saved, we saw the difference between what she paid, which was 68, and what it was before the sale happened. And that's it, yeah. Any questions?
What's the second step?
Yeah, this yellow thing says work out the original value by dividing in the second step. And then, because it had a little extra thing, how much did she save? Normally they just want to know what was the original value, to be honest. Normally $80 would be the answer.
This is really
But they just wanted us to do an extra thing at the end to work out how much she saved.
18, 22.
Yeah, that's right. Yep, so now we do the worksheet on page 18 to 22.